Do you want to share your screen?
Yeah.
Okay.
Yeah, Kevin, I'm seeing his. I was going to tell you that, so.
Yeah, I'll stop sharing mine briefly. You can take over. Somebody's smoke alarm is chirping at him. Yeah, if everybody go ahead and mute, that'd be great. There you go. Awesome. Thanks. Thanks, Kevin, Shane, Steve. Look, I just want to remind everybody, with all the events of what happens over the pandemic with PASS and everything like that, that this is the community, right? This is it right here. This and somebody's smoke alarm, which is chiming in the background. This is the SQL Server community. This is the data platform community. So this hasn't gone away. This hasn't changed. This is still very much strong and going. And good job on these guys for keeping these communities alive. All right, so quick check. Everybody can see my screen, right? Okay. So this is an incomplete tour of SQL Server DMVs, covering the most important topics and getting you started on getting the most you can out of these crucial performance indicators. Everybody could go ahead and mute. We'll get rolling in just a sec. So today's presentation is delivered with a little bit of a delay from Teams. If you have any questions, you can go ahead and put them in chat, or you can raise your hand, and then one of the moderators is going to bring your question to the floor at some strategically placed question breaks, and then of course at the very end. All right. So everyone can benefit from the knowledge of these helpful DMVs, these helpful tools, from developers to report writers to DBAs of all levels of experience. So there are far too many DMVs to be covered in the scope of this presentation, right? There's tons of them. These are just the most useful and most popular that I've built over my career. That smoke alarm is gonna, yeah. All right, so somebody hand that man a 9-volt. Getting anything out of the DMVs is gonna require you to try them yourself. I'm gonna have some short, quick hitting labs throughout. I'm actually not going to do all of my labs, but you can. And so you'll be able to download the toolbox that accompanies this presentation and the presentation from my blog at SQLTac.com. And I encourage you, for all the labs that we skip and all the labs that we do, to run these on your own systems, right? If you're the type who wants to write your own diagnostic queries, to explore the internals of SQL Server, to design your own maintenance plans, or maybe your company has bought one of those great SQL Server maintenance and performance monitoring tools that are all fantastic sponsors of Saturday events and user groups and things like that, but you want to understand the data better as it's coming out of SQL Server, this presentation is for you. If you didn't think it was possible to do such things, to like manage things without a third-party monitoring tool, then this presentation is for you. And if you use somebody else's maintenance or diagnostic queries, but you want to understand the objects that are being called, that are the root of those diagnostic queries, this presentation is for you. So I'm going to stop for questions throughout and save time for questions at the end too. We're probably going to go over an hour if I had to guess. All the slides and code samples will be posted at my blog, and then this is a lot of the code from this presentation is straight from my old consulting team's still updated SQL toolbox on GitHub. It's out there for free, it's open source, and a lot of the labs that I reference in slides are just going to be files in that toolbox right there. Okay, so what is a DMV? Right, I haven't intentionally have not explained what the acronym means yet. For those of you who don't know, so is it the Department of Motor Vehicles? No, that's no. It's the DMV proxy service. Great idea, by the way, $1 million idea. No, is it the DMV mega musical featuring just one of the Blue Men from the Blue Men Group? No, it's not that. Is it the DMV? No, it's the DMV. It's not Run DMC. It's not Dave Matthews Band. It's dynamic management views. These are in place to provide system transparency, and most of them work all the way back to SQL 2005. That's version 90. They have a bunch of new DMVs that are coming out, and we're going to note some in 16, 17, and SQL Server 2019 that have come out as part of this presentation. The DMVs we're talking about today are the foundation for countless third-party SQL monitoring tools as well. And they all fall into a category of DMOs, or dynamic management objects, because some are dynamic management views, DMVs, and some are dynamic management functions, or DMFs, functions with parameters. For these purposes, though, and for the presentation, I called them all DMVs because I can make more jokes about DMVs. But they could also be called DMOs, Dynamic Management Objects. That acronym is already actually taken by Distributed Management Objects, though, so DMVs is actually a more popular name. So some of these require that the database also be in the compatibility mode. The individual database be in the compatibility mode to be supported, and some do not. So even if you're running SQL 2016 with SQL 2005 compatibility mode, the 2016 DMVs, most of them actually will still work for you. So that's okay. And some towards the end of this presentation have been introduced more recently, like in 2019, we'll call those out. And then often DMV changes are being included in older versions via service packs or cumulative updates. So something may only work in SQL Server 2012 Service Pack 4 or SQL 2016 Service Pack 2, but not before that inside the major release. So pay attention to that as well and keep your servers patched. And most of this content applies to SQL Server, all the service level objectives of Azure SQL, SQL Server on Linux, Azure SQL Managed Instance, across the board with very few exceptions. Okay. These are the read-only permissions that may be appropriate to give developers in production, because most of these DMVs only require view server state and view database state, which does not require you to grant permissions to see any data. So it may be a regulatory okay to provide this same data to developers, to report writers, things like that. I just heard a Teams chime. Are we still online? We're still good?
Still good?
Still good. Okay. I don't know what that sounds. All right. So don't grant permissions to individuals, though, of course, because that's what I've done wrong here, right? Don't grant permissions to people's names. Always grant permissions to security groups in Active Directory. And as a DBA, it's your job to enforce that. And like they mentioned earlier, for a lot more on best security practices, I'm actually going to be giving a presentation all about that kind of stuff tomorrow at the Database Professionals virtual meetup group online. And you can check out a link to that blog as well. All right. So ready? This is going to be a fast-paced presentation. Again, if you need to stare at something a little bit longer, you can always download the slide deck. It's actually already out there on my blog to take a look at the code. But we're going to go pretty fast. So let's go. First, we're going to talk about weight stats. So weight stats are powerful diagnostic tools for performance, and there's actually 3 of them to be aware of that give you access to these stats at different levels of granularity and different time. So many performance suites, some of the third-party products out there that are, again, great sponsors of user groups and the Saturday events and conferences and things like that. Many performance suites, third-party products, do little more than incorporate the weight stats data for charts in their dashboards. But they're also great sponsors of user groups and tech events. So, like, look, it's cool, but they don't have magical access to the SQL Server. You have the same access to the same data that they have out of these dynamic management views. So let's look at the first one, DMOS weight stats. This is aggregated wait times, and it records when something inside SQL Server and one of the worker threads has a wait and retains that wait. It records the count of tasks experiencing that wait, the sum of the time, and the max time per wait. And there are over 1,000 more or less documented wait types in SQL Server 2019. We're actually working to document more and more in these continuously as they get introduced into the SQL Server engine with new features and new patches and things like that. Most of these wait types, the 1,000 or so wait types, aren't important or common. And it's best to exclude some of these that match a string like sleep, because those are related to SystemDB startup waits or background tasks and shouldn't be part of user performance. In fact, there are a bunch of wait types to ignore. And there's a long list of wait types that doesn't really matter. It probably indicates that your server is idle, for example, where something is still waiting on listening or something like that. Your laptop, for example, that doesn't have a very busy production load is probably going to have a whole lot of wait types at the top of its list that aren't that important. Again, it's important to look at these on your production server to understand what your production server generates as far as a baseline and then how those things change over time. So let's talk about some of the common wait types that you should care about that are important. So anything LCK, these are lock waits. These are a sign of transaction contention, and this is just natural to any relational database. You need to observe this lock waits, and you can actually identify sys.dm tran locks over time. It could be that you have poor queries or indexing that are creating too many scans that block other requests from happening. This is just basic measure of locking and blocking that happens in SQL Server, which everybody should experience from time to time and probably has observed. Synchronous availability group replicas could also increase this lock weight because unlike asynchronous, synchronous puts some lock burden on the primary replica. And if you have a lot of these lock weights, you need to consider the enterprise solution for locking and contention, which is not no lock. It is not read uncommitted, the isolation level. The enterprise solution for a lot of locking and blocking problems is RCSI, or what's called read committed snapshot isolation, which changes read committed to read committed snapshot and allows reads to read through Tempdb so that writes don't block reads as much. This is a pretty big deal, and it's a much more advanced topic as far as contention goes. But if you are having lock issues, if you're seeing lots of blocking and blocking chains occur on your SQL Server, and we're going to talk about how to observe those, and it's not just SP. If everybody can go ahead and block, mute themselves, block their sound. And we're going to talk about a lot of that blocking as well and how to observe that. But this is an indication that you have that happening at scale, and it's a way to measure this over time. Okay, so the next one is CX packet. This is a clear indication of excessive execution plan parallelism. And the CPU is struggling not with the overall workload, but with the parallel nature of the workload. You need to look into your max degree of parallelism, your max stop settings. It may be appropriate to reduce large parallel queries from impacting performance in that way. Max stop can be configured server-wide. It always could have been, but in recent versions of SQL, you can now enforce a different max stop per database. And via query hints, you can enforce a different max stop per query. And you can also enforce max stop by bands of queries after identifying them via the resource governor. And this is actually one of the more useful and common implementations of the Enterprise Edition resource governor feature. If you're struggling to figure out how to reduce max stop, but you can't put a max stop across the whole server, for example, because the whole server hosts many different databases for many different pieces of software, right? SharePoint, for example, recommends max.1 across the board, but if you're co-hosting other databases on that server, that becomes difficult to do because they may have different recommended max.stop settings, right? Well, newer versions of SQL Server, you can actually do this much more granularly. CX Packet recently, and this is one of those things that was introduced in 2019 and then also introduced into 17 and 16, CX Packet has been split into 2 different wait types. This is a little advanced. Don't worry if it's a little over your head. Just understand, though, that as a result, in these newer versions of SQL Server, CX Packet will actually be lower after the patch compared to the workload before that. It doesn't mean it's faster. It just means it's being reported a little differently because CX Packet has been split into CX Packet and CX Consumer. Because CX Packet used to be from both threads that consume and produce data, and producer threads were the most problematic, the most impacted by parallelism, and most affected by out-of-date statistics. And so these are the ones you actually had control over and could fix. Consumer threads, you had less control over. You had less ability to impact and move that dial. And so those were less important, and so they've been split out into CX Consumer. Together, in the newer versions of SQL Server, they combine into what CX Packet used to have. OLADB. This describes weights associated with external communication via an OLADB provider. We're actually going to talk about that a little bit more. Commonly, this is seen by SSIS, Office packages, including like Excel or Access. Mercy on you if you have that in your environment. Linked servers using the OLADB provider, third-party tools, things like that. Also, internal DBCC checkdb commands can drive up a lot of OLADB communication. That's not necessarily a problem. It's just an indication that it's coming from those sources, and it helps you identify the load put on by those different sources. SOS scheduler yield is a clear indication of CPU pressure when this is the highest weight. Too many runnable tasks for available threads. A SQL task stopped and then yielded to another task to give it the CPU, and as a result, the other one that has yielded is recording this weight type. Increasing the CPU capacity, speed, for example, is the simplest, but this is also pretty expensive and it's a crude way. You need to look for and reduce CPU intense queries, and we'll help you identify those a little bit later on. But again, hiding it with iron is not the right strategy. I have a few more of these that are actually important. Resource semaphore, the request is waiting on memory to be gathered. This is an indication of memory pressure, and it's unlikely just to be purely caused by insufficient system memory. I mean, yes, you could go and add more memory, and as a DBA, it's against my religion to ever refuse more memory to be added to my server. But more likely, resource semaphore is because of poor query design, poor indexing, inefficient execution plans that result from those two things. So keep a lookout for that. And then page latch and page IO latch. It's important to make a distinction between these two because page latch, the one that does not have IO in the middle of the wait, this has nothing to do with physical IO. It has nothing to do with disks. Page latch is all about memory pages. This could be Tempdb temp tables that are being overused, could be an insert statement into a hotspot on a table that has a sequential key, and we're going to talk about that exact scenario in the next slide. Page IO latch, and then anything in the last 2 letters of that. Page IO latch is physical IO. That is reading from a disk into memory. And so hard disks or SAN or the SSD or the flash or whatever you have actually storing your data, those are actually struggling to keep up. Now, often this is because of inefficient code, not a performance problem with the disk, often, but it could be. Or, somebody is running Microsoft Access and they're pulling in the entire 5 GB table to their desktop or something like that, having to scan an entire table that's not used to being scanned in an OLTP system, for example. Again, it could indicate slowness of your hardware, but it's more than likely poor application query design. So let's talk about that one case, and this is actually something new in SQL Server 2019 that you're going to want to be aware of. This is a new option called Optimize for Sequential Key. It's an index option, and it's specifically for tables that have an identity or a sequence, or really just have any kind of always ascending incremental key as the clustered key or as a non-clustered key, which is a very common pattern and a good practice to have for OLTP because it reduces fragmentation. We're going to talk about that a little bit later. And so it's just generally a really good idea to have your surrogate keys be identity columns or something like that. It's a way I design all my tables, for example. But There's one downside to them, and that is if a whole bunch of insert queries are concurrently running. So, 15, 20 users are trying to insert data into the table at the same time. That page that contains the highest identity key becomes a bit of a hotspot. And so there's contention at the IO level and in the memory level for that page to write that because of concurrent SQL sequential inserts. This isn't just me inserting 1,000 rows in a cursor. This is 20 me's trying to insert one row. That's what I am talking about. And so by specifying this new SQL 2019 option, optimized for sequential key, you can actually get up to 30% faster performance for concurrent inserts. This is a big scaling issue and a big scaling bonus boost for OLTP systems. So you should add this to the definition of each sequential key index. This is a breakfast syntax, right? You're going to be doing this every morning at breakfast when you're creating indexes and creating tables and things like that. To get used to using this in SQL 2019, it is definitely something to sell your boss on buying SQL 2019 for if this is a common pattern you have in your tables. And by the way, otherwise, even without optimized for sequential key, still a good idea to use identity sequential keys in your tables, especially in OLTP systems. Okay, a couple more of these wait stats and we're going to move on. So Async Io Completion, this is waiting on disk IO. So again, that IO in the middle means it is storage related, not memory related. This could be growth, auto growth events, or writes to log files. It could be backups and restores. And so at that point, it's perfectly normal. This is expected during long running SQL backups, as are backup IO and backup buffer. So not exactly something to be afraid of. And then Async Network Io. This is caused commonly by waits involving the reception of data by remote clients. We have sent the data and we are waiting for it to be received by the remote client. This is almost certainly not caused by the network. There's no switch or cable that has gone wrong. This is almost certainly is caused by poor queries, like a select star with no where clause, and you're literally waiting on the remote client console to receive all the data to display. So look for queries with very high row counts. Recommend things like paging happen in your SQL Server queries, which only get like the first 10 results, just like a Google search result, something like that. And this will be caused by Office applications that query entire tables like Access 97. Again, you don't want to have that in your environment. It will cause async network IO. So when do you want to analyze DMOS wait stats? When do you want to analyze wait stats at all? So you want to look at this all the time, but you want to look at it as a baseline. Whether or not your system is currently healthy or troubled for performance, start trending a baseline. You can do this yourself. Obviously, there's lots of third-party tools that do this for you, but you can do this yourself. Determine which weights are impacting the performance server-wide, and it's really one of the best DMVs for that kind of thing. This number, though, is a forever growing aggregate. So it's going to start at 0 when you start up the SQL instance, and it's just going to grow forever. So over time, recent changes you made in the last week, if the server's been online for a month, are not going to move the large aggregate numbers very well. So for your most performance sensitive servers, or all of them that you really care about wait stats for, you're going to want to consider a regimen of storing these numbers, these aggregating numbers, every week or every night or something like that, and then comparing the difference between the numbers to see as they grow over time, and then handling whenever the numbers reset because of a reboot, something like that. And we're not going to do this lab live today, but this is a way, there's some examples of how to do that. You can also manually reset this DMV, I believe, but yeah, storing those and then comparing the difference over time is a great way to see what did my wait stats look like yesterday, even though this DMV is always growing aggregate numbers. And it's aggregated at the instance level. It doesn't include live data. It doesn't include request or session level data. For those, you actually need the next DMV, and that, ladies and gentlemen, was a segue. So you need to show weights for current active requests with this DMV, DMOS waiting tasks. This is not aggregated. It is only live data. Not much different from the current wait information that's returned in DM exec requests, and we're going to talk about that one later because that is the core of a lot of different things. So it's not that special, but it is one of the wait stats DMVs. DM exec session wait stats shows weights aggregated for the current session. So if you can identify a session for a specific application, this wait DMV is going to return all the DMVs that have been incurred by that entire session and all the queries for that session, aggregate for the entire session, as long as the session is alive. So you could look at one particular thread from an application or something like that. You could also capture what the wait stats involved in backups, and that might be a way to start troubleshooting why your backups take so long, for example. And there's some good labs here for you to start experimenting and digging around with these numbers in your performance servers here. And again, I had the link at the beginning of the presentation. I'll have it at the end where you can get all these toolbox scripts. Okay. Next, DMV, the DM exec query stats. This stores performance information about cached query plans in memory. But the rows don't persist after a plan is removed from cache. So for example, after the SQL Server is restarted. So this is just what's happened in recent time, and how recent really depends on how busy your SQL Server is and how much memory you have, how much is in that cache, for example. So you can really just promise that it's recent. It may be hours worth of data. It may be days or weeks worth of data. It really depends. It provides a SQL handle. And this is not the first time we're going to see this concept of the SQL handle and offsets. And these offsets are integers that allow you to pull out the script text of a handle of SQL and then find out what in that batch, what statement in that batch is actually executing. So for example, if you have a very long stored procedure, or if you push in a very long batch, you can actually identify what statement in that stored procedure out of the many statements in a stored procedure or batch it's actually talking about. And you can pull the stats out for just that statement. So that's really useful, right? And then you combine that with another DMV, DM exec SQL text, and you pass that handle and you join on the offsets, and then you can pull out the queries. And don't worry, I have some examples of how to do that. And we're going to see that same SQL handle and offsets pattern in a couple DMVs. This is a great way to find the worst query plans in terms of like total worker time, rows affected, duration, things like that. And it records the total writes and reads, and you can use that to measure activity. And so there's this lab worst query plans that we had in my old consulting company's toolbox for a long time to help identify like the biggest, baddest queries that had been run on the SQL Server recently. But we don't really use it anymore because there's this new thing called Query Store that was introduced in SQL 2016, and that feature actually contains more and better data and functionality when it comes to retrieving the biggest, baddest queries. So for the first part, this worst query plans, these are all stats for this DMV per plan, not per query. The Query Store actually has the ability to identify a query and then different plans that query has executed. If you're not familiar with the Query Store that was introduced in SQL 2016, if you have not started using that for your own performance tuning, it's not on by default in your SQL Server databases. It is on by default in your Azure SQL databases. Go turn that on. Start collecting that data. It's incredibly useful for performance monitoring. So again, a little bit more on the Query Store. It was introduced in 2016. Starting in 2017, it actually tracks your wait stats. That first thing we talked about too. So it is really cool. And it's a built-in free feature of SQL Server. You just need to turn it on and start looking at the reports that come out of Management Studio. It tracks the performance of queries, not the execution plans. And that is a really distinct difference because it can help you identify when a query has suffered degradation, when it's no longer running very well because the plan changed. And so that worst plans in cache query had been our strategy to identify the biggest, baddest plans. The Query Store is one step better, helping you find the worst queries regardless of plan, and maybe helping you find a better plan, right? Query Store can say, hey, this plan ran like this and this plan ran like this, much faster. Let's just tell it to use the faster plan. And that works. It's a pretty good step. So what if SQL Server could use information about regressed queries, queries that ran better with an older plan than a newer plan, and then it could have a history of execution plans to make decisions to automatically use a better plan? Well, yeah, what if it could just do that automatically for us? Why should we have to wait on our own action to do Query Store? So now it can. This feature of SQL 2017 called Automatic Plan Correction is actually based on the Query Store. It can automatically shift a query to a better plan if it recognizes a certain regression, and you can configure that. By the way, Azure SQL Database, where this feature was originally designed for, already does this for you. So automatic plan tuning is based on the query store. Again, it's SQL 2017 or higher feature. Go do some more research on this. We're not going to talk about this that much more, but you can force a query to a newer, from a newer, slower plan to an older, faster plan. And again, it's not on by default. You must enable it, and it'll automatically force by default, like I think it's 10 seconds. And here's the simple code to turn it on. It's really not complicated at all. You can also accomplish this manually yourself, of course. Basically, write the same thing using a host of DMVs that are underneath the query store, including one Dmdb tuning recommendations, which you can then take action on yourself if you wanted to. Okay, I'm going to go ahead and stop for any questions. And then we'll go ahead. No, I mean, maybe I don't know. I'd have to have a lot more information on that. Generally, Query Store is really safe to run because it's stored asynchronously, right? It's got a cache that it uses, so it's going to add a little space to your user database, and you can configure exactly how much space you want it to add to your user database, so it's not without, you know, the footprint on the disk. And then it does everything it records in memory. So it's not going to churn up a whole lot of I/O or disk paging or stuff like that. It's not like turning on a trace or anything like that. Because it's all recorded asynchronously, one, you're not going to see stuff show up in Query Store live. It's going to show up however long you set it to, 15 minutes or so later, because it's buffering that cache from memory to disk only periodically. And so that 15 minutes or so by default, that also means you would lose that much data, up to that much data when you restart the SQL Server, because it would not have buffered that cache down to the permanent storage disk. No, there's generally no significant issues with Query Store. I recommend, and when I was a consultant, I still did recommend turning it on every database that you care about performance for. Query Store itself can crash when it runs out of space, and when it goes on that 15 minutes to flush its cache to disk, if it doesn't have enough space in the disk, and by default it's very small, it depends on what version of SQL Server you're running, but it only has access to maybe 100 megabytes in some versions of SQL Server to store that data. That's not a lot of data to keep track of all the things that Query Store beneficially keeps track of for you. So by default, on a large database, you're going to want to monitor how much space Query Store is taking and give it access to more, right? In a very large database, it's still not going to be a very significant amount of footprint, relative to the whole database. So you're going to want to increase that. I have seen the Query Store go up to 10 gigabytes on some databases just because it had a lot to do. There's also some things with Query Store that you can do as far as pruning out plans, and there's actually a sample of this query that I just updated on the Query Store best practices document that helps you identify plans that are either like system plans or they're ad hoc plans, or they're plans that only ran once, and get those out of Query Store to kind of clean up the trash a little bit more aggressively than default. So, but no, in answer to the original question, I have no experience in long experience doing this with Query Store crashing a SQL Server. Happy to wrap more about that though. Okay, any other questions? So that's correct. A lot of the OS specific DMVs are going to either not work or work differently on Azure SQL. I'd have to know which one. And this should be well documented as far as they're different. A lot of them will not show up unless you're in the master database of Azure SQL DB, that logical server master database of Azure SQL DB. But in regards to the things that don't work in Azure SQL database, there are usually replacements for that. For example, there are some DMVs where you can track the DTU utilization for Azure SQL database, which are good replacements for some other ones out there that for an on-prem installation, the SQL Server product itself. Go check out some of the Azure SQL specific DMVs. And in fact, there's some in that same toolbox that I don't mention in this presentation, where you can go look back and track via a DMV the DTU utilization for an Azure SQL database, for example. Those do not have the OS. So it really depends. Yes, most of them do work, or they have some kind of facsimile of the same information. Some of them it doesn't make sense too, right? Because some of them are like the registry settings or the disk space settings. Obviously, those don't apply to Azure SQL Database. That's the whole point of having a PaaS offering database, right? So some of those, it makes sense that there's no analog for them inside Azure SQL Database. And even in the MI product, the SQL Managed Instance product, which is real SQL Server, but it's totally managed for you, some of the DMVs behave a little differently because of that. All right, great. Let's keep rolling. We've got a lot of content to cover. So Sysdm Exec Sessions. So this is queryable session info. This is connection identification info. And it replaces the old system view sys.sys processes. And so we were actually talking about this before the presentation began. I've been doing this presentation for 10, 11 years or so. Back when SQL 2000 was still, a semi-respectable version of SQL Server to be running. Now it is definitely not a respectable version of SQL Server to be running. But if you're still used to seeing anything that's sys whatever without a period between it, like sys processes, as you can see right here, that's old, right? We need to get rid of that. And so Sysdm Exec Sessions replaces that sys.sys processes. And so Sysdm Exec Sessions contains things like host name, application name, login time, stuff like that. It's very often joined to Sysdm Exec requests, which shows current activity of things happening right now. So sessions are connections that have happened, connections that are open. If you have a window open in Management Studio, if you have an Object Explorer open in Management Studio, those are all sessions that are open. They're not doing anything, so they're not incurring current requests, but the session is still there. So sessions and requests, very common way to see, one, what is connected, and two, what is happening. And you join those together so you can see the connection info for what is happening. This is the main hub. And you're going to see this DMV probably more than any other DMV because it's the good DMV providing request information. It has that SQL Handle and Offsets system that we talked about earlier so that you can identify exactly what statement inside a stored procedure is currently running. Again, joining that to DM exec SQL tasks. And so sessions and requests have been combined in one of our toolbox queries here, sessions and requests.sql. One of the queries that we run a lot as a much better replacement for SP-who or SP-who2. And if you're a DBA who knows who those are, you run those to see what's currently happening and more likely to see what's blocking, to see if there's any blocking on your SQL Server. But a lot of times, if you just look at that rightmost column, that blocked by column, it'd be kind of hard to eyeball what's at the middle of that blocking chain, right? I see 623, 137, 533. I see a bunch of 533s, a bunch of 623s. I see 137, a whole bunch. 0 means it's obviously not being blocked by anything, but what's really at the root of this blocking chain? So we developed that sessions and requests toolbox back in, well, you can see 2011 from this screenshot. And we worked to identify what has the longest blocking chain. And so by default, the first order by in this query is the length of the blocking these, which is an inverted list of all the things that is blocked by. As you can see right here in row 1, session 623 is blocking all those other requests. And yeah, this is really ugly. It turns out that was a reporting services report that had been kind of just running forever because somebody chose some unwise filters. And so we killed that and got the server running again that morning at around 10:04 a.m., if you can tell. So kill 623 was what cleared up all the blocking. The whole blocking chain cleared up like that. But it would have been really difficult to figure out what was at the root of that blocking chain just by eyeballing that blocked by. That's one of the reasons that we use the sessions and request queries so much. So again, that sessions and requests query and the DM exec request, you're going to see a lot of really useful information in there. There's actually a %complete column in there. It is unfortunately not as helpful as it could be. It only applies to certain operations like backups, restores, and check DBs. But it's a great way, one, to see how long this backup's running if you don't have the progress bar in front of you, right? So if the progress bar is on some other screen or a laptop or something like that, and you want to see how long that backup is taking or how long a restore is taking, you can look at that %complete and then comparing that %complete column to the start time of the request, you can actually generate an estimated completion time as well. really easy to do just by simple math. And so that backup restore progress in the toolbox contains a lot of that information. And so it's another way too to figure out if something is still running. And so if you have a CheckDB running on a suspect database and the CheckDB is not finishing and that %complete column has stopped changing, that's a bad sign, right? And so it's one way just to make sure, hey, this thing's taken a really long time. Is it still making progress? That %complete will tell you that information. And then Sysdm exec input buffer. If you're familiar with the old dbcc input buffer function, that's actually still not deprecated. Deprecated means that it's been replaced and it will go away at some point, and you shouldn't use it for new development. Sysdm exec input buffer is the same way to get that same information out, to get the last command issued from a session, even if there's no live request. So it's whatever was buffered into SQL Server from that connection most recently, even if that command has already finished. That's actually really useful sometimes to figure out what the heck is going on with this, especially if you're trying to troubleshoot something like an uncommitted transaction. Okay. Enough about sessions and requests. Let's move on to indexes. These are index DMVs that you should know, and I'm breaking them down into 3 groups here. There's physical stats DMVs that help you evaluate the need for index maintenance. We're talking about fragmentation there. There's missing index DMVs, which help you design new non-clustered indexes. And then there's index usage stats, which help you evaluate the value of existing index usage. Let's go through all of these, because these are all activities that you as a DBA should be doing regularly, right? So first, let's talk about fragmentation. This is the root of all fragmentation monitoring queries, regardless of who wrote them or where you got them or how you're doing defrag, they're using this DMV. This average fragmentation in % shows a logical fragmentation for indexes and the extent fragmentation for heaps. So it replaces the functionality of DBCC show contig to an extent. That's a pun. Extent is an 8K page. That's a little SQL joke. Tell that to your friends. Dmdb index physical stats will still show tables without clustered indexes. Those will show up as index ID equals 0. This is a heap. This is bad. I will have arguments about this. We can go on Twitter and argue about the heaps and stuff like that. Almost always, heap is a poor design, I would argue, or an oversight, right? Every table in SQL Server should probably have a clustered index, and that clustered index is ID equals 1. Every other index on top of that is 2 or higher. And that also includes the column stores if you're doing that as well as your clustered or your non-clustered indexes. So index physical stats has that average fragmentation on a scale of 0, which means it's not fragmented at all, and you'll never see that, to 100, which means it is perfectly fragmented. Everything is perfectly randomized and out of order, making more I/O to get the same data back. And that's the definition of fragmentation from a performance standpoint. High fragmented indexes means you got to do more I/O, the slowest of all the operations, to get back the same data. Reduce the fragmentation, you need less I/O to get back those rows, right? So you may find it beneficial to perform index maintenance to remove fragmentation if you see that average fragmentation % is greater than 10. This is kind of a urban legend or just kind of a best practice out there if you see fragmentation higher than 10. But the optimal percentage of fragmentation to hit may vary on larger systems. You may find that you don't really get any value. You don't notice any difference doing index fragmentation or index defragmentation, index maintenance to remove fragmentation until it gets up to 30 or 50%. And on very large systems, when you have small maintenance windows and you're desperately trying to keep up with your fragmentation, it's probably more realistic for you to increase that to 30, 50%, something like that, and only do maintenance on the most fragmented tables. And that's actually the strategy. We'll talk about that in a sec. But if you're an old DBA like me, you probably remember some of these old DBCC commands. So alter index reorganize has replaced the old DBCC index defrag. Alter index rebuild has replaced DBCC DB reindex. If you still have maintenance plans running the DBCC commands, time to rewrite them. They are deprecated, which means they are going to go away eventually. Whether or not we actually ever pull the trigger on those things is up for debate, but they have been replaced by superior functionality from these new commands. And then you can also do this cool thing, alter index rebuild all, which rebuilds all the indexes on a table. And remember, a rebuild also updates the statistics. But this is not recommended, that rebuild all thing, maybe for development and things like that, because you only want to do index maintenance where it's needed. So when do you want to use this DMV? You use this while your application's in production to identify tables that are generating fragmentation over time, and then only perform index maintenance on the individual indexes as needed. And then if you have partitioned tables, because you've implemented horizontal partitioning in your SQL Server, you can actually only perform the index maintenance on partitions of indexes, and that can save a lot of time on very large tables, right? So ideally, you do your index maintenance by using a rebuild online or reorganize on the top fragmented indexes in every maintenance window. So when do you have your maintenance windows? You could do them nightly. If you're a 9 to 5 business and you have those kind of operating hours, try to squeeze in a maintenance window every night, even if it's just an hour, to do a little bit maintenance on the most fragmented tables. And that's a great way to just kind of take the top off of the stack of the most fragmented tables. If you can only do maintenance windows every week, every weekend, for example, you have to take advantage of that, right? And so custom scripts should have a selective approach. Do not do the old index maintenance rebuild tasks in the Management Studio maintenance plans. However, these plans have gotten a lot better. And so in the newer versions of SQL Server, I actually do recommend, especially for clients that don't have a lot of expertise in this kind of thing, to do the maintenance plans rebuild tasks, because look at all the options you have. So on the left here, you see SQL Server 2014, and you notice there's no options to do index maintenance on indexes selectively. It's the entire database or all databases. And this is needless, right? If you have time to do it on the weekends, great, right? Doesn't hurt. It's going to create a whole bunch of log activity, right? But ideally, you're going to do index maintenance only where it's needed. And the only where it's needed is that optimize index only if options at the very bottom of what you see here on the right. And since SQL Server 2017, you can actually use the maintenance plan to perform rebuild index tasks online with the sort results in Tempdb, which I always recommend, with the fragmentation higher than whatever percent you want. And maybe you skip smaller pages. If it's a very small table, who cares? Just only do index maintenance on the larger tables. Maybe you only want to do index maintenance on tables that have actually been used in the last few days. That's actually a pretty cool feature, right? Now, one feature it doesn't have, which I would like it to have, is the ability to stop after an hour. And so one of our scripts in our toolbox, and one of the reasons we wrote it that way, is that you could give it a start and an end window. And I recommend doing this for yourself to stop or have it not start any new index maintenance, or use the new index maintenance pause feature, right, to take advantage of small index maintenance windows that you have maybe every night. If you only have an hour every night, take advantage of that. Figure out a way to have your maintenance only run inside that hour, either by not starting anything new or by pausing, stuff like that. Okay, so this is a function, and so there's a parameter here called mode, and limited means it's the fastest, and this is also the default. And this only scans branches at the, page level, branch level pages, not leaf level. And obviously there's way more leaf level pages than branch level pages. And it only returns basic metrics, but it returns all the metrics you need to really identify fragmentation. There are other modes here which provide more detailed information, but they're not going to give you more useful information necessarily when it comes to identifying fragmentation. The default limited should be all you need just for the purposes of doing index maintenance. Sample detailed return other data, and some of the columns in this DMF, when they're returned, only show up when you do sampled or detailed. You shouldn't need those on a recurring basis. Keep in mind, though, any of these modes, this whole DMV can still have an impact on performance. So don't do this right now. If you're running on your production server and you just kicked off this DMF, go ahead and stop it. You don't want to do this right now. It's going to cause a spike in your I/O and potentially dump a bunch of stuff out of memory. You want to do this during maintenance windows only, right? You want to do this outside of peak business activity. Because even in that limited, the fastest default mode, it will have a noticeable impact on a production SQL server. Maybe I should have moved that slide up if any of you are super quick on experimenting right now. But there's some good labs here. I'm actually going to do these labs because they bring up some really good talking points. So let me go ahead and go over to this. I'm going to create a script right here. You should all be able to see, right? All right, great. I'm going to insert a bunch of records into this table. I'm just going to drop a table, create a table. I'm going to add a primary key. I'm going to add a non-clustered index, so it's got 2 indexes. I'm going to actually insert twice this number because I incremented this a little bit. So I've got now 250,000 rows in this table, and then I added a needle to the haystack, and that's useful in some things. And so then we go look at the fragmentation level, and this is a script that's also in the toolbox just called dfrag, and you can see at the heart of it is this DMV. This is our DMV that we're talking about right here. This is our DMF, and we're even specifying limited right here. This is a default, obviously. Let's go ahead and run the fragmentation level. Now we can see on that table that we just created, we've got a pretty high fragmentation level, right? We've got 78% fragmentation. And that's the number of pages. It's not a partition table, and we've got 250,000 rows. But something in the back of your mind, something is making the hair in the back of your neck stand up straight. And you said, William, you just inserted 250,000 records into a brand new table. How is it already fragmented? Anybody catch it? Anybody catch what I did to create fragmentation upon insertion? I use the unique identifier data type and the new ID function, which just returns a random unique identifier, and then that's my clustered key. This is a classical anti-pattern in SQL Server to introduce fragmentation, 78% fragmentation just upon insertion of the data. I haven't done any updates or any deletes or any things like that, right? So this is bad, right? I got to have more IO, more pages to get back the same rows. Let's do the same thing with just an integer, with that identity thing that I talked about earlier. And I'm even going to use, because I'm running this in SQL Server 2019, I'm even going to use that new optimized for sequential key keyword, right? Really cool. Let me do the same thing. I'm going to end up with the same number of 250,000 records. And let me go look at my fragmentation levels by default. So the second row here is doing it with an integer. This is the grown-up way to build tables, right? Not with a GUID. And then if I look over here, after inserting 250,000 records, I've got 3% fragmentation, right? 1% on average. And look at the difference in pages. Now, yes, integers is 1/4 the size of a unique identifier, but I'm taking up much less data to get back the same rows, right? The same rows, the same data in the table, right? That's pretty big impact on data type decisions. We're not just talking about fragmentation anymore. We're talking about data type decisions, which are really bad, and table design decisions. And then you say, well, William, hold on. I've heard about this thing called new sequential ID, this function where you can get sequential unique identifiers, right? And that sounds pretty cool. So let's do the same thing here. We'll add a 250,000 rows into this table with the same design, same everything, right? The same kind of data. I got 250,000 rows. Let's look at the fragmentation level here. And so actually, this NSI, this is the third way to do it. Okay, so this is pretty good too. My fragmentation is about the same as it was with an integer, but look at that page count right there. A GUID is still 16 bytes, right? Unique identifier is 16 bytes per row, as opposed to an integer, which is only 4 bytes per row. So right away, we're still using 25% more pages to store the same text data, right? We're just choosing a different clustered key. But then there's a monumental gotcha with the non-sequential ID function is that that sequence can be reset. It's not going to continually ascend over time. There are a huge number of scenarios, including restarting the VM. In Azure SQL, it could happen virtually anytime for you. Anytime that seed changes, because that seed is tied to the NIC's MAC address. Anyway, it is a very common scenario for that that new sequential ID to have its sequence seed change, and then of course it's writing a new pattern which is going to create the same fragmentation as if it were randomized. Essentially, it could start writing before, it could start writing after. You're now writing at the beginning of your table instead of at the end, like a good sequential key goes. It is not a good solution. I will still argue about using unique identifiers for the keys of your indexes, clustered and non-clustered, in a table. You can take that to Twitter as well. We'll fight about about it. And same thing with heaps. We'll have all sorts of arguments. It'll be fun. Anyway, it's a good idea, and this is a really good demonstration of why you shouldn't do that. Right? Let's not do this this unique identifier thing. It just creates fragmentation, which we have then observed with this. And so one of the other things that this query, this defrag query does, and you can see it's concatenating together the commands to do basic index maintenance steps, which is kind of cool. This alter index reorganize is always followed by an update statistics. This is important because the reorganize step does not update the stats. Right? The rebuild does. And so you notice here, I'm doing a rebuild command, and that does not update the stats because a rebuild destroys the table, recreates it in place, and as a result has to update the statistics for the table. So whenever you're doing index maintenance, it's either rebuild or reorg and update stats. It is not rebuild and update stats. That is wasting your time. And it's not just reorg, because then you're not updating stats, and that's bad, right? Okay, let's get back in it. One bit of trivia. Why did the Microsoft Windows 7 release candidate download page break? And if you haven't read this blog post by Paul Randall, it's essentially what we just talked about. Somebody created a table inside of the database that tracked the downloads. The table had a unique identifier as the primary key clustered index, became so fragmented that the response time of the website started timing out. So let's not do that. Okay, let's keep moving on. So if you wanted to track the fragmentation level of your traditional row store indexes, that last DMV, that's the one you talk about, right? If you wanted to start talking about your column store fragmentation levels, there's a new DMV just for that. And if you haven't heard of column store indexing, you should. If you have 10 million or so records in a table, you should consider something like column store. Column store was actually introduced in SQL Server 2012, so this is not exactly groundbreaking stuff we're talking about. It's 9-year-old technology, but it really was made most useful in SQL Server 2016. In 2016, column store indexes, when they're created as non-clustered, and that's just the naming convention, they're writable now. Before SQL Server 2016, a column store index made your table read only, so it was really only useful for like nightly data warehouse refreshes and things like that. It still had a lot of utility there. But in SQL 2016, they became writable, and so now they can be deployed in OLTP systems just alongside your traditional row store, and you'll probably see that differentiation in documentation, by the way, the difference between column store and the indexes that we've had all along. Those are now called row store indexes. So column store indexes have their own DMV for fragmentation. You need to include this DMV in any of your maintenance scripts. So if you have column store indexes in your database, and you have index maintenance that's happening, make sure that you're taking some care of your column store indexes. You may find it necessary to reorganize, and by the way, that's all you do to a column store index. You just reorganize it. You don't rebuild the column store index. But you may find it necessary to reorganize the column store index multiple times before all the indexes, row groups, go from compressed into tombstone status. And you'll see that happen. And so we have a lab there to demonstrate. Okay. Any questions about index maintenance, defragmentation, unique identifiers, anything like that? It makes a lot of sense in most options. What it does is it removes load from the user database. It removes some of that effort from the user database's transaction log and puts it in Tempdb. And in a lot of systems, Tempdb is faster and it has its own logging. So you're spreading out that IO hit into both the user database and the Tempdb. And in databases that are in full recovery mode, you're taking some of that log activity out of the user database and putting it in the Tempdb as well. So overall, it is beneficial in almost all scenarios. I almost always use sort in Tempdb unless there's something that's preventing me from doing that, like an older system that I think there's some options where you can't do sort in Tempdb for certain scenarios. But I do it every time I can. It's good for performance. It's good for logging. And if you have and good for the DBA, right? And if you have one of those systems where it's striped storage, right? So not everybody can afford a full flash SAN these days, right? But sometimes you have some SAN and some like hybrid stuff. So you have some spinning metal and you have some flash stuff, and you've put your Tempdb in flash, but some of your other disks are still on spinning media, right? Well, this sort in Tempdb allows you to take more advantage of the faster storage that you've put under Tempdb. And by the way, if you do have an environment like that, like a Dell EqualLogic SAN or something like that, that has both spinning disks, spinning metal, and flash or SSD storage or something like that, you should do that. You should put Tempdb in the fastest media possible first if you have limited access to that in the faster media. So the question is, in like an Azure VM, where do you put your Tempdb? Yeah, so sort in Tempdb option. Yeah, even if there's no differential in the storage performance underneath the user database or Tempdb, I would still take advantage of sort in Tempdb because it does spread out the IO hits and it benefits logging, right? It generates less logged activity. And in a VM, if you're running in a SQL Server installation on an Azure SQL VM, there's that D drive that is the local SSD, and that is the perfect place to put Tempdb because, like the D drive, the Tempdb is transient, right? It goes away when the SQL Server is rebooted. Never, ever, ever put anything else on the D drive, of course, because it is transient, and everything in it goes away whenever the VM is restarted, right? That's the fastest place to put Tempdb in general, is that local D drive in an Azure VM. And MI, you don't have nearly as much control over that kind of stuff, so you don't need to worry about that in the MI. All right, good. Any other questions? And I know we're at an hour right now, but I've still got like 30 slides to go. So if you're still with me, I can keep going. All right. So let's keep moving on. We'll talk about missing indexes now. This was my favorite feature introduced in SQL 2005. Hey, everybody go ahead and mute, and we'll get back to talking about missing indexes.
Hey,
if everybody could mute. Thanks. Okay, let's talk about missing indexes because this is my favorite feature introduced in SQL 2005. And yes, I'm an old DBA and I remember what it was like to see the release of SQL 2005. And I'm not bragging, I'm just old. A set of DMVs records anytime a query plan recognized a need for a new non-clustered index that could have improved performance. So it becomes like a Christmas wish list for SQL Server. Please, please, please give me these indexes. They would help performance this much, right? Because it records the estimated statistics on costs and the improvement of that cost of that new index. And so these missing index views, there's 3 of them, and there's a 4th one that I'm going to talk about at the end. These are passive. They're already running, and they don't need to be enabled. If you don't already know about these, they've already been collecting data for you since your SQL Server was last restarted. So go ahead and take advantage of them. They are cleared out whenever the SQL Server is rebooted. They're also cleared out whenever you make any kind of schema change to that table, right? If you change a column or change a data type, obviously the old index recommendations may not be valid anymore. And so it wipes the recommendations just for that table if you make a change to the table. And it only recommends new non-clustered row store indexes. Will not recommend the clustered index for you. You have to design that well yourself. And if you have a heap, it will actually still recommend non-clustered indexes, but you should go and create the clustered index first, of course. And it will not recommend column store, XML, spatial, or any other type of indexes, those special type of indexes that you have. It's just for row store non-clustered indexes. Of course, it was generated in 2005, well before column store indexes existed, right? So the missing index views must be used with sobriety, though. Do not create every missing index suggestion. Your database will suffer. The reason why is that non-clustered indexes exist physically. They're copies of your table of just, portions of those columns. And thus they have overhead to every write. It has to keep up all those indexes every time you insert, update, or delete a row. So if you go and add 50 indexes to a table, your writes are definitely going to slow down noticeably, even if your reads perform admirably, right? Writes can still benefit from a non-clustered index by making the source, only by making the source of the write more efficient, right? So if you're doing like an insert into select from, the select from part could get faster due to a non-clustered index, even though the write may marginally or maybe even not noticeably slow down with each new index added. There will be a point, of course, where you have too many non-clustered indexes, and that's bad. So indexes should be created to help many queries, many suggestions. Suggestions may only differ by the columns in the key or the includes, and maybe only by a small number of columns. So you should always combine missing index suggestions together. Look at those common key columns that are in the same order and combine the include list. You may see a suggestion on column A, including column B, and another suggestion on column A and B, including column C. Well, that second suggestion completely overlaps the first because it's got an overlapping key in the same order. And then the includes can just be tacked on at any point. It doesn't really matter what order the includes are in or what the includes contain. As long as that key is the same and it overlaps the other, so you should only create that second index. And then combine your new index suggestions with existing indexes on the same table. So it may be that that first index already existed, but you've got a new suggested index that would overlap that. Well, drop that first index and recreate a new one. Now, just be careful dropping in existing indexes if they are enforcing uniqueness. That would actually change the programming of the database. You would never want to drop and replace a unique constraint. That could break stuff, right? So when do you want to use the missing indexes views? After recording actual usage in production. Just be careful about doing this in development. It may provide some valuable data. It may also be misleading because developers and QA people are writing troubleshooting or data validation queries and things like that, not actual usage in production from actual users in the actual application, right? That's what you want to capture. You also want to try to capture an entire business cycle, right? If you have a weekly payroll or month-end reporting or quarterly or annual reporting, try to capture that activity because that's going to be very valuable. We're going to talk about just trying to capture the entire business cycle a little bit more later on too. That's important in multiple processes that you have. And in SQL Server 2019, there's a new DMV for missing indexes that actually is a part of the query store, that awesome feature that was introduced in SQL 2016. It returns the latest SQL handle and offsets, that handle and offsets thing that we've talked about 3 times now, right? To find the latest query that generated the missing index need. You couldn't do that before. Before SQL 2019, all you saw was the missing index suggestions, and it could be one or many different queries that generated that missing index suggestion, and you don't know. Well, now you can actually identify the query. This may be valuable or more interesting than useful. You can actually identify the query that is most recently generated that missing index suggestion, and that's pretty cool. One final note on missing indexes views. Since SQL 2008, Management Studio has been popping this green text up over the execution plans of your queries. Don't do this. Again, you don't want to just go and create a missing index suggestion, even if it's a very important query and you have a very high impact missing index suggestion. Again, go back to these rules. Combine all the suggestions together and then combine the new suggestions with existing indexes as well to make sure that you're not creating a whole bunch of bloated indexes in your database. Take a look at the whole picture of all the missing indexes and existing indexes before you create or replace any indexes. So really just treat this green text that you see here in Management Studio, treat this as an alert. Hey, I should go take a look at my index. And so let me do real quick a lab right here where I'm going to generate, using those same tables that I created before, I'm going to generate some activity right here. Just doing some queries, and then I'm going to call this new DMV in the missing indexes query right here, and I'm going to see that activity show up. So those are the queries that I just ran, right? I just ran these queries looking for the string BBB, and where I found them right here. These are the information coming out of the DMV. right? Here's that handle and the start and stop, and that's how I actually generated that text right here. And there's the text you can see right there. You take the offsets, and then you use the offsets to generate the actual statement. And then you can see it's got a cost like that. So that's a cost 5.84. And then that much of the cost of that query would just go away if only you gave me the index I was looking for. And if you go to the top of this query, you can see, and you're probably familiar with this, this is the index that's actually being recommended, right? You can see the index that is recommended based on that activity now. All right, let's get rolling again. Missing index is very valuable. Sometimes developers aren't taught this stuff. And so you go to them and tell them that SQL Server has this engine internally that tells you what indexes to create. So you can stop just creating a single column index on every column in the table, which is an awful anti-pattern that I see a lot of developers doing. Tell them all about this. Train your developers on how to use this stuff because it's going to generate much better indexes. Okay. The last thing you want to talk about with indexes and DMVs is the ability to track index usage. This is what helps you prove that the indexes you created a month ago are actually helping, right? So this DMV is always, you don't have to turn it on, it's always passively tracking all access to applications. It resets with the instance, or if the database is detached, stuff like that. And it retains the data through maintenance operations too, so that's useful. And then you join it to sys.indexes and things like that, and you get data out that shows you how many reads in the form of lookups, seeks, and scans, how many reads an index is getting, that's beneficial, versus how many user updates the index is getting. And that's when the index had to be updated because the table was written to. Right? So if the table has an insert, update, or delete happen, the user update records that, and that's where you paid the penalty for the index. So if you look at an index and you see that it has 0 reads, that index isn't being used. And then that user updates tells you how many times you paid the penalty for that index, right? So if you see an index with 0 reads and 1 million writes, that index isn't doing you any good. If you have captured a business cycle, like a weekly payroll, month-end reporting, things like that, you should then feel confident in being able to drop that index and move along, and it's not going to hurt anything, right? So only take action from the index usage stats after a stable period of actual production usage, right? And again, those are the 3 blocks of indexes that you need to care about, index DMVs that you need to care about, and you should be caring about on a regular basis on your performance-sensitive databases. All right, let's do the DMV rapid fire round where I have like basically 1 DMV per slide for a little while, and then we're going to finish up and we can take any more questions. I'd be happy to chat. All right. So Sysdmos performance counters. This is perfmon stats from inside C-SQL, right? You don't need to write WSQL, which is the WMI language. You don't need to go to perfmon. You don't need to buy some third-party tool to scrape this stuff out. For the perfmon counters that start with SQL Server, you can actually query those from inside the SQL engine now. Now, what that means is that you can't get some stuff like CPU or the page life expectancy out of the memory. Well, actually, you can get that from out of the SQL Server buffer. You can't get things like the physical storage counters. You still have to go to the operating system to get those, either by perfmon or some other way out of WMI to get those kind of things. But anything from inside SQL Server, you can get from inside this DMV. It is slightly more involved to read some of this stuff. So for example, buffer cache hit ratio, which is a very common memory metric. When you observe it in perfmon, it actually is 1 metric from 0 to 100. When you observe it in this DMV, it's actually 2 numbers. You got to divide them together. And actually have a lab sample right here where you can get some really cool metrics and build your own metrics tracking inside SQL Server for the SQL Server performance counters. And let's talk about memory. So Sysdmos memory includes total and available physical memory and some other breakdowns of that memory. It also has flags for high or low memory signals inside Windows. So the application can use those high memory or low memory flags, which are just 0s and 1s, to automatically scale itself down or up. If you have an application that's capable of spinning up or spinning down more parallel threads, for example, this actually comes from the Windows virtualization feature, where there's internal Windows flags that allow it to just send up alerts that, hey, I've got available memory, or hey, I've got low available memory. And so applications can actually have access to that from within inside a SQL DMV. That's pretty cool. And then some more OS stuff. And again, some of this OS stuff is not going to work in Azure SQL Database, but it should still work even in SQL on Linux. Yes, that's why it's called Sysdm OS and not Sysdm Windows or something like that, right? Because even Windows and Linux, this should still all work in different ways. And so you can see Sysdm host info actually returns information about the host operating system. And in your inventory of diagnostic queries, you can document what operating system everything is across all your platforms. And you can see it returns similar data for both Windows and Linux. And then services, and obviously this doesn't apply to the PaaS offerings as well, because those don't have services you have access to. But for SQL Server, you can actually query the services, the last startup time, whether or not SQL agent is running, for example. So if you ever have an issue or a SQL agent mysteriously stops running or crashes or something like that, and you didn't know about it for a while, you can actually query that same kind of thing and maybe alert yourself through something that's not in SQL agent, of course, to see if there's something happening there with the SQL agent. So you can actually see the status and all these things. You can also look up the service accounts of all of the things. And this is really useful for inventorying the features of your SQL Server estate. Something you should definitely do in case you had to rebuild or something like that. You'd have all that documentation there, right there. And this is a DMV that exposes that for you, including some of the settings like instant file initialization, for example. You could see that. Sysdm Server Registry, obviously this is Windows only, but you can query the registry for SQL Server keys. And so you can find out the locations of some of these things. This is another really good way to document things en masse without having to go into each regedit in each Windows server, right? SysOS volume stats is a way to bypass those WMI calls you used to have to do to find out how much space you have on disk. Now, unfortunately, because it's a SQL Server exposed DMV, it only shows you volumes where SQL Server files are present, right? For space on all disks, even where you don't have any SQL Server files, you still have to use that old command, exec xp fixed drives, to return all the drive space. There you have, and there's some scripts right there in the lab. And then SysDmdb log stats. This is a newer one. It was introduced in SQL 2017 and then ported back to SQL 2016 Service Pack 2. This is a DBA-friendly one-stop shop for all your transaction log needs, including your VLF size and counts, the log reuse reason, the state of the backups, things like that. And it replaces and is superior to DBCC log info. So if you have DBCC log info in any of your maintenance plans or your inventory plans or health checks or stuff like that, you should look at this new DMV instead for newer versions of SQL Server. DMIO, I told you we were going fast. DMIO virtual file stats includes an ascending counter that can be used to measure the data volume over intervals, so you can see the reads and writes issued to a file, the reads and writes on a volume, the waits and stall per file, and the overall IO latency here. So this is really good for diagnosing potential IO problems. And then DMOS ring buffers. This gives you access to XEvent sessions that have their storage option written to ring buffer. So for example, the system health XEvent session, which is always running by default on a SQL Server instance, that's the only way to find a deadlock that has already happened without setting up a deadlock trace or something like that, right? You don't see many deadlock traces being set up anymore because you can get all that deadlock information out of that system health XEvent session. And so you can use the ring buffer. The system health also writes to an XEL file. You can use those things to get the deadlock out of the recent cache. Now, remember, these are rolling windows, so you have to pull the deadlock out relatively recently. It's not in there forever. I believe it's like a rolling 20 megabytes total striped across 4 files, for example. And there's some labs right here what you can use. You can also use that DMOS ring buffers to get out the CPU utilization for the last few hours in your SQL Server without having to go to perf on or task manager or something like that. And now let's talk about availability groups. There's a few DMVs for availability groups. DMHADR cluster, cool story about availability groups. The initial code name for that was Hadron. And it was actually a really useful acronym, Hadron, H-A-D-R-O-N. It was coming online when the Large Hadron Collider in Europe, the particle accelerator, was starting up, back in like 2011. And so the code name was Hadron. It was cool. It was sciencey. But then, of course, the marketing people were like, availability groups, always on. Hadron. But so cool. But you still see that Hadron, that HADR stuff represented in some of the internals here, like you see here in the DMV. So Sysdm HADR cluster and another one, HADR cluster members, allow you to get some really good information out of availability groups as far as, well, all the counters that they have, including the current configuration, the endpoints, the current RPO and RTO. So like how far is it behind, how long it's going to take to replay everything on the secondary replica, the last commits, the latency, things like that. And this is far more detailed than the dashboard that you get for availability groups in Management Studio. And so this is what we use to, or my whole consulting team used to monitor availability groups. And there's a AG monitor script right there that we always use. And you're going to want to run that on the primary replica, whatever is primary at the time, or connect to the listener, because that's going to show you all the information. All right, just one more left, and that is Dmdb page info, which is a brand new SQL 2019 DMV that replaces most, but not all, of the functionality of DBCC page. And if you've ever done any like advanced troubleshooting into trying to figure out what's actually on a page, this may be happening because of corruption or other kind of pretty advanced things that we're talking about that we're not going to get into. You can use DBCC page to get that information out for that page. And when the DM exec requests, for example, has a page resource that is the wait resource type page, it can help you investigate that and actually return the data out of that page for certain wait resource types. And it is limited because it doesn't help you with other wait resource types like key. But there's this new function in SQL 2019 FN page res cracker that can help you get that information out of the page. And again, that could be pretty useful when it comes to data corruption detection. Okay, I know that was pretty advanced, but that is everything I've got. Here's all the links that I put at the end of each of my slides that really helped me while I was developing this presentation over the last few years. Last decade, really. You can see some links that we have already talked about and some more. Here's a couple books I wrote for Microsoft Press before coming to Microsoft. Most recently, our 2019 book, which came out right as the pandemic hit. Perfect timing for a book sale. And then please support your local STEM initiatives. Here's a local STEM nonprofit that was in Baton Rouge, Louisiana, where I'm from, that I used to volunteer for and still donate to and help out remotely. Please reach out and share your knowledge with the next generation, especially with folks in your local community that need to find new career momentum during the pandemic. And if you can, donate to your local STEM education nonprofits. All right, information on me. You can find all the slides and the labs at my blog right there at SQLtact.com. My name is William Assaf. I'm a senior content developer for Microsoft on the SQLDocs team. I just joined Microsoft back in November, and so former SQLSaturday, former Microsoft Data Platform MVP seemed appropriate to put up here. I have time. Any questions from the audience? The execution time was the question? Yeah, so the execution time. So if you're looking for a query that is already finished, I would probably pull that out of Query Store in SQL 2016 or above. Before that, you'd actually have to look not at the query, but at the query's plan. And you'd have to identify what plan the query was running at that time. And then you could pull out the query's execution time and the last execution time using that DMV that returns the worst query plans in cache. I forget which, but if you were looking for the current execution time on a query, that is definitely going to be in DM exec request to see how long a query has currently been run, how long it's been running, how long since it last started, and its start time for the request. You can find that in DM exec requests. And so if a query has been running for a very long time and you want to find out how long and when it started, and then you can also find out by joining it to Sysdm Exec Sessions when that session logged in, for example, right?
Will this presentation be available? Are you sending the link for this, or is it just posted at your site?
Man, I try to say that every presentation. That's okay. SQLtact.com. It's my blog. There's actually already a link up there to this slide deck and a link to the toolbox.
Perfect. Thank you.
Yeah, there you go, right there. Awesome. Awesome. That was great. Good questions, everybody. It was a pleasure.
Thank you.